Today's resource notes are on solving proportions. We're going to solve them in a few different ways. Don't forget, you can always pause and rewind. Make sure that you keep them neat, because you will be able to use these for some of your tests. Okay, so what is a proportion? And I'm just going to leave a space over here in our notes for some academic language. Okay, so write this down. We're going to have space for academic language over here. Okay, and let's just jot some down that we may be looking at. We have proportion. We're going to have quotient. Fraction. I know that sounds simple, but we're going to really get into it. Okay. Common denominator. Okay, and I'm just going to leave those over there, and what I want you to do is I want you to keep those in mind as I'm talking, and tomorrow or the next time I see you, we're going to go over this in case you don't understand any of this academic language. A little further down, we're going to put something review, or things that we have learned but are going to need to remember, and we'll just quickly jot some things down under there also. Okay, so what is a proportion? A proportion is a set of equivalent fractions. So you can jot that down if you want to, so we can talk about it tomorrow. It might be a good idea. I am not going to write it down now. So a proportion is a set of equivalent fractions. So let's start off with our first example. Okay, and let's start off with 1/2 is equal to x over 26. Okay, so our ratio for these two fractions are the same. So 1 is half of 2, so we need to figure out the number that is half of 26. And the first way we're going to think of to solve these, you learned in 6th grade. So we look at 2 times some number is 26, and that number is 13. And if we multiply the numerator by the same number, okay, we get 2 times 13 is 26. And 1 times 13 is obviously 13. So our variable x, I'm going to throw the word variable over here. Our variable x in this problem, we solve it to be 13. Okay, so that's one way to think about solving it. Under review, I'm going to put down here that a fraction with the same numerator and denominator is equal to 1 whole. Okay, so write this down. So when we're multiplying 1/2 by 13 over 13, we're really just multiplying it by 1, which is the identity for multiplication, so it doesn't change the value. Okay, so a fraction with the same numerator and denominator is 1 whole. Okay, so that's just something we're going to need to remember. We've learned it before, and it's going to keep cropping up. All right, so that's the first way to solve. Let's look at a second way to solve a proportion, and let's use the example 2/5 is equal to, oh, that wasn't the one I wanted to do. I'm so sorry. You can erase. I'm using a pen, so I'm not going to be able to erase here. Let's use the example of 24 over 3 is equal to 48 over x. Okay, so you can easily think about this the way we just did, like 24 times some number is 48, and we're going to multiply 3 by that same number. But let's just think of it a different way. Let's think of it as equivalent fractions are going to have the same ratio, and I'm going to throw ratio because I've said it a couple times over here under our academic vocabulary. So what does that mean? That means that when we divide this fraction, and a fraction just means division, okay, when we divide this fraction, we start from the top, the numerator, we're going to have 24 divided by 3 equals 8. Okay, the other fraction is going to have that same ratio. So if I said 48 divided by our variable, we don't know what it is, something we don't know, I know that I'm going to get 8 as the same answer, correct? So 48 divided by something is 8. We can do that in our head. That should be 6, right? X equals 6. Okay, and you can double check yourself by doing it the same way. 3 times 2 is 6, and 24 times 2 is 48. So it's just a different way of looking at it that might be a little bit easier for you. Which leads us to the third way, which is basically creating and solving an equation from a proportion, which means that we don't always have to have perfect numbers like we had in the first two examples. As long as you're able to solve an equation, you can do it this way. So what do we have? Let's try an example of 15 over x is equal to 12 over 100. And over in review, I'm going to put something that you should be remembering maybe about now. Any number over 100 is going to represent a percent, or it could represent a percent. So let's come down here, and we're going to write any number, and I'm going to use hashtag for number, over 100. Okay? Can represent a percent. And that becomes important in this chapter because we're going to be solving percents, and that's one easy way to do it, right? So this could easily be 12%. So 15 divided by some number, because a fraction's just a division problem, is equal to 12%, really. So how are we going to do this? The easiest way to do it is to multiply both sides by the common denominator. Okay, and if worse comes to worse, you can't think of a common denominator, you just can multiply the two denominators together. That's going to be the easiest way to do that. And it's not going to be the least common denominator always, but it will be a common denominator. So again, I'm going to throw that down under our review, that you can find a common denominator by multiplying the two denominators together. And when you get into pre-calc, that's going to come in really handy, maybe even algebra 2, by multiplying the two together. Okay, so I'm going to remind you right now, if I'm going too fast for you, pause it, go back, write down what you missed now that it's all up there. Make sure that you are understanding this before you move on. That is one of the perks about doing this via video. Okay, so what I'm going to go ahead and do is I'm going to say I have a denominator here of x, right? And on the other side, my denominator is 100. So in order to find a common denominator, I'm going to multiply together. What does 100 times x look like? Well, it just looks like 100x, and we take the multiplication symbol away. Okay, let's put them in parentheses. Actually, it's going to be a little bit easier. So 100 times x on this side, and we're going to have, my 3's in the way here, 100 times x on this side. Okay, multiplying that together, remember we're going to go back and we're going to remember that the first thing in our review, a fraction with the same numerator and same denominator is just equivalent to a whole, or 1, which means we can cancel it out. So on this side, we have 100 times x times 15, right? But since I have an x on the numerator, I know it's a little high. I messed up that 3's in the way. I can cancel out that x, and I can cancel out this x. So basically what I have is just 100 times 15, which is going to give us 1500 on one side of the equation, of the equal sign. Then on the other side, I think you've probably guessed it already, I have 100 on the numerator and 100 on the denominator, so I'm going to cancel those out because that's just one whole. And I just have 12 times x, so I'm just going to write 12x. Now we're just solving a one-step equation. 12 times some number is 1500, so if I divide both sides by 12, I should get my answer. So let's see. So if I divide 12 by 12, look, I have just a whole, so I can cancel that out. And then I take 1500 and I divide it by 12. So I'm going to cancel this out. So I'm going to have x on one side is equal to, and then 1500 divided by 12. I'm going to go ahead and let you use your calculator here. Let's do that. 1500 divided by 12, and we get 125. So 125 is my variable in this particular case. And it doesn't matter which way you write this. I always like to put my variable first in my answer, so I'm going to rewrite it as x. My variable is equal to the number 125. These are the same. These are saying the same thing. I just always like to put my my variable first. And I'm going to throw down under review while I'm thinking about it. You may need to review solving equations, and we'll do some of that in class too. Okay. Oops, what's happening over here? Solving. It looks like I ran out of space. So throw solving equations. Oh, there we go. Under your review here. Equations. That's kind of messy. Okay, solving equations. I'll clean these up before I post them. I can do some erasing and stuff. So let's just do one more practice problem here. Number 4. And let's do something that's not too easy. Let's try 7 over 15 is equal to x over 12. This will be a good one. Okay, so remember, let's find that common denominator first, and it's going to be 12 times 15. Now, you could look at the calculator here for a second, you could do 12 times 15, and our common denominator is going to be 180, but it's a lot easier, you guys, if you just write 12 times 15 the way I wrote 100 times x. So I'm going to put 12 times 15 here, and over by the 7 I'm also going to put, I keep writing that number too close, 12 times 15, and hopefully what you're seeing is that you can cancel out some numbers, right? So this 12 and this 12 will cancel out, and this 15 and this 15 will cancel out. So I have 7 times 12, so let's do that. 7 times 12 is 84 on this side, and then I have 15 times x, which is just going to be 15x. Then divide both sides by 15 because that creates a 1 there, right? So we can cancel it out. And then 84, I'm going to do this on the calculator, divided by 15 is 5.6, right? So 5.6 on this side equals x on this side. These 15s cancel out. But as you know, I like to rewrite it as x is equal to 5.6. All right, so make sure you have all of this written down. If you just wanted to watch it first, maybe that would have been good, and then you can write it down when you're done. We'll go over the academic language the next time I see you. And if you have any questions over the stuff I threw down under review, come prepared to talk about them. Remember, you should have also left a space at the bottom of your page. You should have a little more room than I have on this computer program, and we're going to write the algorithm for this the next time.